I always invite him back, and he always says yes, which is great. So today we have John Harrison from Lucid. It's a tech company based out of Sandy. And I know a couple of the campuses have had the pleasure of having John's team come out and visit, which is great. And John is the vice president of engineering, and he's been with Lucid for 7 years, but he has vast experience, with coding and computer science in many capacities. And so I'm excited for y'all to hear about him today. But before I turn it over to John, just a few housekeeping things. Remember, keep your mics and your cameras off. And then if John or I ask you to post in the chat, then you're good. But please don't post in the chat unless we say it's time for that. And then we will be having an announcement at the end of the virtual guest speaking engagement today. So students, make sure to stay tuned. Campuses, make sure to stay tuned as well for an exciting announcement regarding wrapping up the year and some cool things we have coming. But with that, John, I will let you take the lead, sir.
Thanks so much. Hey, everybody. My name's John Harrison. I want to just tell you how I got started in coding and talk a little bit about how you guys can get started in coding and get a career in coding as well. So I grew up in Centerville, Utah, and went to Viewmont High School. I saw Bountiful just checked in, so go Davis County. Went off to California to Stanford to get a computer science degree, spent about 10 years working for IBM, had my own company for about 8 years, and now I've been at Lucid for about 7. Started off programming, and now I'm in management, which in some respects means I talk to programmers about their feelings all day, but just try to help keep things moving there at Lucid. It is a really fun place to work. In fact, in about 2 weeks, we're going to have our annual hackathon and retreat, which means we get to spend a lot of time coding and then also, going off on adventures. Here's a picture from one of our retreats in the past. This is Thunder Mountain. It's a mountain bike ride near Bryce Canyon, which we all did. Company's much larger now. We're about 1,000 people at this point. We make 3 products, at least 2 of which you might have heard of. Lucid Chart, which is a diagramming solution, Lucid Spark, which is a virtual whiteboard, and then Lucid Scale, which allows you to visualize your cloud infrastructure. So if you've got a bunch of stuff up in Amazon's AWS or Microsoft Azure or GCP, we show you what your servers look like and how they talk to each other. But I'm going to talk a little bit, and I'm actually going to switch. In 1983, maybe I'm switching. Let's see, I have lost my mouse and everything else. There we go. We'll switch over to this thing. Can you guys still see this? Can you see a blinky cursor now? Any indication? Hopefully you guys see my screen. If not, somebody please tell me. 1983, my dad brought home a Commodore 64, which was a computer that looked like an extended doorstop, and everything was contained within the keyboard, and you literally plugged it into your television. And when you turned it on, this is all it did, is it said ready, and you could hit enter and nothing would happen. And it was just waiting for you to tell it commands in BASIC. And so the first command I learned, which is completely inscrutable, was we got a manual out and it said poke and then 53281, 1. And that should change a bit in the memory that tells it what color the screen is. And we were like, oh my word, we can change our television from blue to white. And we were very excited. And then we learned some more. And in BASIC, you have to have line numbers for your programs, which is really a terrible idea, but that's how it was organized. And you could say print, if I could type print, and then you could type code to success rules or something like that. And then 20, go to 10. And so I don't know if anybody knows what this is going to do, but if I type run, which is the command to execute a program, it's going to do line 10, which says print something to the screen. And then line 20 says, just go right back to 10. And so we get an infinite loop of craziness. In any case, we'll kill that little computer. And that got me going. And we'll skip through some slides here. Whoa. And so I want to share a quote from a fellow IBMer. This is Fred Brooks, who wrote an influential book about software development maybe 30 years ago. And I thought this was interesting, and it's a little bit wordy, but I want you guys to think about this and kind of internalize it. The programmer, like the poet, works only slightly removed from the pure thought stuff. He builds his castles in the air, from air, creating by exertion of the imagination. Few media of creation are so flexible, so easy to polish and rework, so readily capable of realizing grand conceptual structures. And so what does this mean? This is saying that as a programmer, you can take your thoughts and make them into something. And so, when I was a kid, I wanted to make things move around on the television screen. And basically whatever we could dream up, we could make happen on the TV. And then later, went on to develop more complex and sophisticated programs. And I want to talk about this kind of in terms you guys might understand, which is, as you program, you kind of develop a spell book, almost like, Harry Potter. When Harry Potter starts out, he only knows one or two spells, but as he, as you go through the series, he learns more and more things, and you can string them together in order to accomplish complex tasks. So, obviously the poke 53281, 1, that's about as arcane as, as a magic word. And hopefully the programming you guys are learning is a lot more clear than that. But by learning these little things that each by themselves did something, you could chain them together in order to build something larger. And the possibilities of that are kind of endless. And that's what excites me about software development. And I want to talk about someone who is not a famous programmer, but has done something that I think is really inspirational. Her name's Dana Lewis. And I'm going to show you a little picture of her. Dana Lewis is a diabetic and had an electronic glucose monitor that would tell her what her blood glucose level was at any point. And then separately, she had another device, which was an insulin pump, which she could tell to give her a certain amount of insulin during the day. And she had these two different devices, and neither of them talked to the other. And so she had to manually intervene, and it was a very mechanical process. Every time she got an alert from her blood glucose monitor, she would go and adjust her pump. And she kind of lived in fear that, at night, sometimes things would go way out of whack, an alarm would go off, and she'd have to wake up. And what she did, I do not recommend to anyone. I am not a lawyer. All these disclaimers, don't go hacking on medical devices. But this is really interesting. She took went online and said, well, this is a computer, the glucose monitor, and my insulin pump is a computer, and those two things should be able to talk to each other. And we should be able to come up with a simple algorithm that will say, hey, when this gets out of whack, I need more glucose. And when this is good, I need less. And was able to find an online community that said, well, we know how the pump works, and another community said, oh, well, we know how the monitor works, and was able to hack together a solution with a Raspberry Pi, which is the small little computer that she's holding there with her right hand. Oh, wait, that's her left hand. I'm confused. She's wearing her watch on her right hand. That's throwing me for a loop. Anyhow, that little clear plastic box with the green in it is a Raspberry Pi. She was able to use that to cause the two different devices to talk to each other, and basically took herself out of the equation in terms of adjusting her insulin levels, and invented basically an artificial pancreas, open sourced that, and made that available to other people. She was about 10 years ahead of the curve in doing this. You can now buy systems like this from pharmaceutical companies, but she was way out ahead because she saw a need, taught herself to program, found a community, and created something that nobody had ever imagined. And to me, that's really inspirational. That gets back to the Fred Brooks idea of you can take your thoughts and build a castle in the air. And in her case, it was this system that changed her life and gave her peace of mind and freedom. And with that, I want to talk a little bit, about what you can do in order to develop your skills and get a job in tech. And I think, at least for me, when I got into college, I knew I wanted to program, but I had no idea what I needed to do in college, and especially during the summers, in order to get a great job. And frankly, I probably did a pretty poor job of it. And so one of the first things you need to do, and I know people hate to hear this, but is to have a great GPA in college. If you're applying to a job where they're getting thousands and thousands of resumes, having a great GPA will help you stand out and will mean that you don't just get filtered out in that first pass. The second is apply for internships. And nobody explained this to me, but there is a whole, interview process, and all these companies trying to fulfill recruiting quotas and whatnot. And the interview process starts before most kids are even aware that it's going on. And so literally companies are trying to hire both interns and full-time hires for the next summer, starting in August. So it's July now. We're going to start looking in August and September to hire, a bunch of people starting in May and June of next year. And so we're going to start that interview process pretty quickly here, as soon as school gets back underway and going to college campuses. A lot of people think, oh, well, I'll get an internship, after my junior year, and then and then interview for real my senior year. You can get internships very early, especially if you've already got the sort of skills that you've developed in Code to Success. And it doesn't hurt to ask. The only thing they can do is say no. I would certainly recommend, if you've got skills, to go ahead and apply as many places as you can for an early internship once you start college. So I know there's a lot going on as a college freshman. You're just trying to get used to, taking classes in a totally different, modality of learning and being on your own. But being aggressive about this can be really important. The early internships are possible. They're harder to get. Once you're a junior, it's really critical in terms of getting a great job coming out of your senior year to have had some internships. And also, it's great for you to get to know different companies, both through interviewing and through working at a couple of companies during the summer. And I want to emphasize this: interviewing is a strange skill. And if companies had a better way of finding really talented people than interviewing, then they would use that for the interview. And what I mean by that is the way you work in school and the sort of things you do for schoolwork are different than the things you'll do in your job. And the things you do in your job are also different than the things you'll do when you're interviewing. They're related but separate skill sets. And interviewing is something that you can practice and you can get good at, so that you're able to put your best foot forward when you're looking for a job. I want to talk a little bit about what I mean by practicing. One is just to interview at a bunch of places, and the more you do it, the better you'll get at it. And in fact, I would suggest that if there's some place you really, really want to work, I would not interview there first. I would interview some other places as practice prior to your interview at the place you really want to work, so that you're warmed up and are good at it. Outside of just interviewing, there's some great places to practice online in terms of programming interviews. And this is usually the part that's most intimidating to people. Is usually in a programming interview, you're asked to solve some moderately complex problems pretty quickly with someone watching you, which are not, first of all, that's not how you do your job, right? Nobody's sitting there watching over your shoulder to see how fast you're going to code up a solution to something. And it's also not how you work in school. You're very rarely time limited. And so it's a weird way to program, and that can cause people stress. and concern, practicing helps a lot. And so here are 3 websites that you can use. And these are just a type of site where you can go. It will give you a programming problem, and then you can go either solve it on the site or solve it on your own time. And it gives you exposure to the types of problems that get asked in these programming interviews, and also gives you some practice, working under a time limit if you want to set a limit for yourself for any particular problem. I want to again emphasize it's different than the type of programming that you learn in school and that you probably are learning at Code to Success. But this is how companies tend to evaluate people, especially given that they've never met them before. And then finally, I'm going to run through just what a typical Lucid interview looks like. We might send you actually to HackerRank or something like that to do an initial problem. Once you've gotten past that portion, there's going to be a 90-minute section of programming problems that are, again, similar to those HackerRank and LeetCode problems, a 60-minute interactive discussion about computer algorithms, and we'll ask you to solve some algorithmic problems, and then 60 minutes talking about your experience. And what we're looking for there is people who take pride in the work that they do and are passionate about it, and we shorthand that as ownership. And so as that's kind of the structure that we have. Other companies are going to have a different structure, but I want to give you an overview of sort of what that process looks like. When we hire people as interns, we put them on an engineering team and just treat them like full-time software engineers. And so you get a really good exposure to what it would be like to have a real job at Lucid. Other companies might have different programs or the special assignments for interns. We don't do that. But anyhow, I want to emphasize the importance of, as you're in school, also thinking about your career, thinking about what you can do to learn about different companies and figure out the types of jobs you might like. As an early intern, it might make sense to even apply for something like a manual QA job, so just to get yourself into the door and see what the software development process looks like and get an inside look at a company. And with that, I am happy to take questions from people about anything at all in terms of career paths, interviewing, software development. Usually people end up asking like what my favorite language is or something like that, but happy to discuss anything you guys would like.
All right, everybody. Now is the time to start thinking of questions, and you are good to post them in the chat. And while we are waiting on questions to come through, John, I'm going to ask you a couple that you've gotten every summer since you've done this. Sure. We'll start with the one you just mentioned. What is your favorite language to program with?
Yeah, and so first of all, some people get really caught up in, oh, this language is awesome and I'm only going to program in this, or this language, is terrible and I'm never going to work in that. And I want to try to warn people away from that attitude. You don't want to be a language bigot, because that will pigeonhole you and limit you in terms of the types of jobs that and companies that you can work at and work with. My personal favorite language is Python. Python is often characterized as the second best language at everything, which makes it really good for a lot of different things. And so if you've got that kind of in your tool belt, it allows you to do a bunch of different things, especially in areas like data science and artificial intelligence. But it also is a great, back-end server programming language. It's kind of a great glue language if you're doing oh gosh, I'm trying to think of how to explain this to you guys. Now, if you're doing DevOps work and like managing large numbers of servers, it's a great language to automate things in for that sort of thing. The other really important language, I mean, first of all, that's not a really important language. It's just a really popular language. The most important language right now is JavaScript, because everyone has a web browser and that runs JavaScript. And so there are different flavors of JavaScript, and you can learn, TypeScript, or, learn different libraries within JavaScript like Angular and whatnot. But just being able to, like, I think JavaScript right now is like, 30 years ago when I graduated from college, it was, everything was C, C++, and a little bit of Java. I think now the baseline skill that people are looking for is JavaScript. And so that, like, having that, mastery of that, even if you don't love that, is going to be important, because you're going to, no matter where you work, you're going to end up using that.
That's good to know. Well, luckily we do have JavaScript included within our curriculum, so that's a good thing we're giving students an edge on. And it looks like we have a question in the chat from our campus in Salem, Utah at the Advanced Learning Center. Could you give us a sample coding problem we could see in an interview or would see in an interview?
Sure. So I could actually probably pull up the actual interview if I wanted to. Let me see if I can do that real quick.
Perfect. And while John is pulling that up, John, I have another question for you, because this one comes up as well. Do you play video games? Do you play Minecraft? Do your kids do that? How into video games are you?
When I was a kid, we had a Nintendo. I like that. I also played a ton of games on that Commodore 64. In my 20s and 30s, I actually spent more time writing video games than playing other people's video games, and got a real kick out of that. And honestly, if you can get into, here we go. If you can get into writing video games, that, like, I just think that's a ton of fun, and a really cool way to again do that sort of castles in the sky out of pure thought stuff thing. And so I would encourage people to, if you can go find a little video game toolkit to go learn to play some. I'm going to show everyone, this is probably not okay. Lucid's going to be mad at me.
We won't tell anybody.
Yeah, I'm just going to share my desktop. Can you guys see my code here?
Yes, at least
okay.
I can.
So when we're interviewing someone here, this is an actual programming section, and we give people about 90 minutes to do this. This is a Python version. You can do it in any language you want. We've got a ton of different languages for this. So part one, we're going to say we want you to write a comparator. And so we want you to sort a list of people in a weird way. And so we want to sort them first by age, youngest first, and then alphabetically by name. And so if we gave you this list right here, we would want it to output this list right here. So Bob comes first because he's 28, and then Jill is 31, and then Andy and Sam. Andy comes first. They're both 32, but alphabetically Andy comes first, if that makes sense. So we're going to give you, here's what a person looks like. And all you need to do is come into compare persons. It's going to give you person one and person two, and you return that. And in fact, I could do this right here. You would say, if P2 dot age not equal to P1 dot age. So if they're not the same, then return P2 dot age minus P1 dot age. And then I would anyhow, and then return. Oh, I think it's p2.name. Anyhow, something like that. And that's the solution to the first one, which is actually pretty simple. And then the second one, we're going to say, oh, if we give you a list of socks that are strings, we're just going to say, oh, red, blue, red, green, green, red. Tell us how many pairs of socks you can make from this. And so in this case, this red would match with this red. Blue doesn't match with anything. Green matches with this green. And so you could return, you would say 2. I can make 2 pairs of socks from that. And then we're going to give you all these lists and see how many pairs of socks can be made from that. And so you would come through here and write a solution. If you guys want, I could actually go through writing a solution for this one as well. Let me know if that's something people would desire to see. We have a set, I'm going to step back. We have a 7-point scale for how well you do. You get 1 point for part 1, 1 point for part 2, and then there are 4 points possible in part 3, which is therefore much more complicated. So in this case, we're going to give you a game, and it has a rectangular grid. And if you were to like click on this O here, it would cause all the adjoining O's to disappear and then blocks to fall down. And so basically, we're going to give you a bunch of rules to this game and some sample code that gets the game going. And then it would, anyhow, and then you input, oh, I want to play B3, and then the board moves, and then we tell you, you have to tell us when the game's over. So that's a little bit more involved, and that takes the bulk of the 90 minutes. The other problems should take, 5 minutes each. If people want, I can go through the solution to the socks, a solution to the socks puzzle.
Would anybody like to see the solution for the socks? Yeah, if you want to, you can post in the chat. All right, we're seeing a yes. So John, let's go for it.
All right, great. So in this case, I'm getting a list of types of socks. And so in Python, I would say, I'm going to say, oh gosh, how do I want to do this one? I'm going to say counts is I'm going to make it a dictionary. And then I'm going to say for color in sock colors. So I'm going to go through each sock that comes in, and I'm going to say if color in counts, then counts of color is equal to itself, counts of color plus 1, else counts of color equal 1. And so that goes through and that says, oh, all the reds I'm going to count up separately, and then all the blues I'm going to count up separately, all the greens, and then I'm going to say, now I'm going to go through again for, I'm going to make a total equals, or I'm going to call it pairs, I guess, pairs equals 0 for color in counts. Pairs plus equals counts of color. So this is going to say, oh, I'm going to get red, the number of red socks, and I'm going to do integer division by 2, and then I would return pairs. And if people really want, I can run this, but that would take some time. Anyhow.
All right. Thank
I
you
have
for
no
going.
idea if any of this made sense. I went through it pretty quick.
I'm sure a lot of our students really loved it. So I've been receiving messages on our Slack channel, because we have Slack for the program this summer, and a lot of them are saying you're an awesome speaker and you're really, really good for this summer. So that you've been their favorite speaker so far this summer, which is great.
That's very kind of everyone. You all have terrible taste.
All right, John, and we'll end with just these last couple of questions that are in the chat. So it was funny, right as you were talking about writing games, someone asked if you ever worked with game development, and so that was very good timing. So,
Yeah,
do you dive into that a little bit more?
Sure. I as a oh gosh, I'll put a YouTube link in. I did a bunch of weird experimental stuff with like VR things, and then I did a 3D asteroids game, which is no longer on the App Store because the well, the App Store changes a lot. Let me find I'll find a YouTube link and you guys can look at it on your own time. This is terrible and embarrassing. This is old. What did we call it? Let's see. Sorry, this is taking a second. This is if you get into this, you're going to see like my entire channel and embarrassing videos of my children and gosh, where is it?
Well, while you're looking for
Okay,
that, John.
I got it.
Oh, nice.
There. Well, I'll just post this in the chat. There's a YouTube video. You can go look at the crappy 3D asteroids game I made like 15 years ago when the iPhone was brand new.
I'm sure it's not crappy. I'm sure the kids would love it.
Anyhow, and I wish you could play it still, but sadly, it no longer works. I should spend some time and write a new one at some point.
Perfect. Love it. Yeah, the students love seeing, personal projects and things like that, and especially when it involves game. We get a lot of questions about game development. So
the awesome thing with games is not only does it teach you programming, but you have to think about graphic design and like what the UI for the game is. You have to think about in my case, like 3D modeling and how to build a world in 3D. There's a lot of math involved in that. And then you have to think a lot about how to make it fast, because it's really easy to make a really complicated game that runs really slowly and is no fun, but making it fast. Oh, I sent this as a direct message somehow to Austin. I'm sorry, I will send to everyone. Thank you, Alessandro. I can't tell what the Mr. Robles. Anyhow, hopefully everyone has the link now.
Also, it's preventing me from sending my messages to everyone. It's not letting me change it to from direct message to sending it to everyone. So yeah.
Okay.
That's okay, Austin.
Yeah.
All right. Yep. So
somebody wanted my email. I am john@lucid.co or john@lucidchart.com. Both of those work, strangely enough.
Perfect. Awesome, John. You're ahead of the curve. I was just about to ask for your emails next. And then I think one more question was approximately how many languages do you know or are you familiar with?
So I know English, Portuguese, and Spanish.
Love it.
And then I can kind of get by in Italian. I avoided getting arrested in Italian once.
Nice.
I accidentally crossed a train track in an illegal spot as a pedestrian, apparently. Then in terms of programming languages, in order of how well I know them, Python, JavaScript, Java, Scala, C, C++, Objective-C. Those are the primary ones. I've also done Visual Basic, ML, Perl, PHP, probably some others that I can't remember. I don't know.
So it's safe to say you have a little bit of experience with languages. So
yeah, and honestly, the thing with languages, like through your career, like I've watched languages. I kind of implied this earlier. The languages change and the underlying technologies change, but the skills of learning a language and being able to solve problems in a language don't really change. And so languages kind of come and go, and different frameworks and technologies have some sort of defined lifespan during which they're popular, and then some long tail of maintenance. There's still people writing COBOL programs on mainframes. I wouldn't suggest that you learn COBOL in order to go into mainframe maintenance. I don't think that's a fun career. But oh yeah, I've also programmed in COBOL and Fortran. But the real skill you want is not a particular language. At first, it's a particular language, but over time, it becomes the ability to let go of a language and learn a new one and become great at the new thing.
Nice. Well, all right, John, it looks like we're out of questions. At least let me double check. So with that, do you have any final parting words for our Code to Success students? They have, this week and next week left, and they're done on the 15th. But any important last messaging for them that you'd like to share?
You guys are learning amazing things, and you're in a time tech-wise that is just incredibly exciting. There's so many great jobs out there and interesting problems to solve. When I was a kid and started out on that Commodore 64, there was no internet to speak of. We had to use floppy disks or tapes to load programs and save things. And now you're all carrying around a device in your pockets that's, I don't know, several million times more powerful than what governments had at the time I was programming on that Commodore 64. And this can not only can you program and make the phone do whatever you want, or a website do whatever you want, but you can access a camera, you can do facial recognition, you can do voice stuff with it, you can make videos, you can network and contact any other computer in the world. That's insane. That is a world of possibilities that I never even imagined when I was your age. And so there's just so many things that could possibly be built and invented. And, we're all looking forward to the amazing things you guys are going to build in your careers. And even if you don't go into programming directly, if you just you might go into UX, user interface design, you might become a product manager and help programmers decide what to work on. You might go into data science and do a bunch of data analytics or machine learning. You might go into QA and make sure that the programmers haven't broken the system every single day. There's a whole raft of possibilities in tech, and looking forward to you guys bringing your skills that you're learning here in Code to Success into that world. And I'm really looking forward to the things you guys are going to invent and build.
Perfect. Those are great final words, John. We appreciate that very much. And thank you for always being willing to, volunteer your time for Code to Success. Again, you are always, don't tell the other speakers this, but probably our most popular speaker every summer, which is why I love having you come back, because there's always great feedback from the students and from the mentors and the facilitators. So we appreciate you very much, John, and thanks for being here. And students, I did mention an exciting announcement that I would be doing at the end. John, you're good to hop off if you need to go for this one.
Oh, I want to hear the exciting announcement, but I'll go on mute.
Now I feel like I've built it up way too much now. So students, as I mentioned, next week is the last week of Code to Success. I know a lot of you have been doing really well and staying on task. And we, really appreciate you devoting your time to a summer program. I know when I was your age, I would have not. I wouldn't even do it as an adult. So that says a lot about how all of you are rock stars. And with that, we really want to encourage all of you to finish your selected course. And so with that, we'll actually be providing incentives towards the end of program. So if you stay on task and you finish your course, we will be doing chances for students to win various prizes and incentives. And, those prizes may include a Switch. They may include a Raspberry Pi. They may include a Nintendo gift card. I mean, we don't know. The possibilities are endless, but just know those can be options. And so we will be sending out further emails detailing what it means to, get entered in for those incentives and staying on track. Your mentors will be providing additional information as well. So keep an eye out for communications either from the Code to Success team or from your assigned mentor or campus as well. And I love, students have been doing really great with finishing the coding foundations course and then going into JavaScript and to React. So keep doing what you're doing. That is boding very well for you. But yes, we'll be sending out more information about those awesome prizes you can win. So stay on task, keep doing what you're doing. A lot of you are killing it. And we'll be in touch. And again, thank you, John. You're fantastic. Thank you to all of the students and facilitators and mentors on the call. And our team and your mentor will be sending out further information once we finalize a couple more details about the prizing. So thanks, everybody. I appreciate all of you. Have a good rest of the week. And we'll see each other next week, I'm sure. Thank you so much, John. I appreciate you.